Video 7.2 is about solving equations using addition or subtraction. So equations may be true for some values and false for others. A solution, and that is what our... Well, that didn't work out very well, did it? So a solution is our key vocabulary word here. A solution of an equation is a value that makes the equation true. So let's look at this little table they set up, and this is right out of your book. You do need to copy this down for your notes because it is important. It says the value of x. So in this situation, let me get my marker. It's 3. Here is the equation they're talking about. The value is in this column. Okay. This equation stays the same throughout. Are both sides equal? So we're making sure that both sides of the equation are equal. So the solution of equation is a value that makes the equation true. Some values are false and some are true. So let's look at this one. If 3 equals x, we just would simply fill in our x right here and use 3, because that's what it's telling us over in the value of x. 3 plus 3 equals 7. Does it equal 7? No. So that's how you can check, are both sides equal? No. You'll see a sign like this, an equal sign, with a line through it. That means not equal. Write that down, make sure you have that. You're going to see that a lot throughout this chapter. So let's look at the next one. We have 4 as our value of x. 4 plus 3, does it equal 7? Yes. 7 does equal 7, so yes, both sides are equal. What about 5? If we fill in 5 for x in this equation, 5 plus 3, does it equal 7? No, it does not equal 7. 8 does not equal 7. So that's our answer. So this is how you can say that some of them are true for some values and false for other values. So we just changed what our value of x actually meant in the same exact equation, and we figured out how to balance each side out. So you can use inverse operations to solve equations. And an inverse operation, basically, all they are operations that undo each other. An example would be addition and subtraction are used as inverse operations. So if I add something, I could just subtract it out. I could undo it. So for our key ideas for this section, we have two properties that we're going to talk about. The addition property of equality and the subtraction property of equality. So go ahead and set your paper up kind of like this, where you have your addition property of equality up on the top. You have about, a couple lines down. You have subtraction property of equality with the words, numbers, and algebra. So with the addition property of equality, the words say when you add the same number to each side of an equation, the two sides remain equal. In numbers, we could have something like 8 equals 8. But if we were to, I'm going to change my color here. If we were to add 5 to this side, it would be 13. And if we were to add 5 to that side, it would be 13. So in turn it says when you add the same number to each side of an equation, the two remain equal. I did the same numbers that I added to both sides and they remain the same. When I look at it algebraically, I have the same thing. I have an equation where it says x minus 4 equals 5. If I were to add 4 to this side and add 4 to that side, I should be coming out with the same amount. Negative 4 plus 4 leaves me with just x, because those two cancel each other out. Equals 5 plus 4 equals 9. So in other words, what it's telling me is x equals 9. Let's just kind of see if that would plug back in. If I filled in 9 for x, 9 minus 4 equals 5. 9 minus 4 is 5, so that means 5 equals 5. That's a check mark, by the way, not a sign of some kind. So for subtraction, the same thing is true. When you subtract the same number to each side of an addition, to an equation, the two sides remain equal. Oops, I should reword that. Should say, when you subtract the same number from, please change that, from each side of an equation, the two sides remain equal. Let's do the same thing with my numbers. If I had 8 equals 8 and I took away 5 from each side, because I took it away from both sides, 8 minus 5 is 3, and 3 still equals 3, right? I'm going to do the same thing with algebra. If I have x plus 4 equals 5, then I can say, if I subtract 4 from that side and I subtract it from that side, I should come up with x all by itself, because 4 minus 4 gives me nothing. It gives me 0. You don't have to actually add your 0 in. And then if I have 5 minus 4 is 1, basically what that is telling me is that x equals 1. So if I did 1 plus 4, it does equal 5. It checks out. We are going to move right on to example 2, because example 1, I have a different thing for you when we get together. And this one is solving equations using addition. So my directions say solve x minus 2 to equal 6. So what you're going to do is you're going to write out your equation. So I have x minus 2 equals 6. Then I'm going to use the addition property of equality, because what I want to do is get x all by itself. So I'm going to add, sorry, let me just put this in a different color to help you. I'm going to add 2, because that will undo the other one. So it's the inverse operation. So I end up with 0, right? Again, you don't have to put that 0 in there. And I'm left with just x, because I didn't do anything to that x. Equals, does it equal 6? No. I need to add that 2 over there. If I'm using the addition property of equality, I need to remember I'm undoing the subtraction over here, so you have to do it to the other side of the equal sign. So 6 plus 2 equals 8, and that's my simplified answer. Then you can do a check, just like I just showed you. Well, if I just said that x equals 8, let's fill it in. 8 minus 2, does it equal 6? Yes, it does, so I can check it. Part B, solve 18 equals x minus 7. Think of how can I get that x all by itself. So I'm going to keep my 18 equals, and notice how this is on the other side. It doesn't matter. I've got x minus 7, so I rewrote my equation. You want to undo, in this case, the subtraction. We want to use the inverse operation and add 7 to it. By adding that 7, it ends up to be 0. I'm left with x. Then, don't forget to do it on this side. 18 plus, my mistake. If I added 7 over here, I'm adding 7 over here. 18 plus 7 gives me 25. So what I'm saying is that x equals 25. So let's just check it very quickly. I'm saying 18 equals 25 minus 7. So 25 minus 7, yes, that is 18. So this is my answer. X equals 25. Example 3 is the opposite. Now we're solving equations using subtraction. So I'm given the equation solve x plus 2 equals 9. So I rewrite my equation, x plus 2 equals 9. What I want to do is I have to right away notice that I've got an addition sign here. So because I have an addition sign, I want to do the opposite of my addition. Sorry, I'm just writing that back in there. My opposite, or my inverse operation, which is getting rid of or undoing the addition. So I'm going to subtract 2 away. Whatever I do on this side of the equal sign, I have to do on this side. So I'll start back over here on the left. It gets rid of my 2's, leaves me with x equals 9 minus 2 is 7. So my answer is x equals 7. To check it, I just put in 7 for my x. 7 plus 2 equals 9. Now if you ever get something that doesn't equal it, okay, then obviously you did something wrong. And the problem is incorrect, so it wouldn't check out. Okay, so now we have part B. It says solve 26 equals 11 plus x. So you rewrite your equation. And because we're using the subtraction property of equality, we want to negate or get rid of, undo that addition. So we're going to subtract our 11. Now here's kind of a tricky one. How do I know what to do? Usually where we see the signs, we can put the signs right below it. But in this situation, we don't, because it's the 11 we're dealing with. So what we're going to do is we're going to subtract it from the 11, because remember, we just want to get x alone. We can still do that because 11 minus 11 gives me 0, right? So I'm left with x. Remember, whatever you're doing over here, you're doing over on this side too. 26 minus 11 gives me 15. So my answer is 15 equals x, or x equals 15. Check your work. 26 equals 11 plus 15. Is 11 plus 15 26? Yes. Alright, here are your 7.2 practice problems. Complete these for discussion for Thursday, and then you'll be all set. So you have 6 problems. I expect that your equations are set up exactly like I just showed you on the examples. And then also, do not forget to check your solutions. So once you find out what k equals, n equals, r equals, s, y, m throughout the 6 problems, you got to fill in during that, for that equation, you have to fill in what those variables would be. So that's how you can check them, and then do exactly like I just showed you in your practice problem, or in your examples. Make sure this is done for your twirl group. Have a good night.